Welcome to another episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet. We talk about it with scientists and engineers here at the Aeros Center outside of Sioux Falls, South Dakota. And we talk to people from across the world as well about this business of using remote sensing to monitor and study the well-being of Earth. I'm your host, Steve Young. Today we want to spend some time visiting about a group called the Landsat International Cooperators Network. So picture this. Across the planet, in rural settings on uncluttered landscapes, there are satellite antennas receiving data directly from a Landsat satellite as it passes 438 miles overhead at more than 17,000 miles per hour. It happens multiple times a day in Australia, Brazil, Canada, Germany, South Korea. You get the picture. The International Cooperators Network has 20 Landsat ground stations in 14 countries spread far and wide across the globe. Why so many, you might wonder? A couple of reasons. For one, all those antennas receiving Landsat data provide a global safety net if problems ever arise getting data back to Aeros, where all that information is processed, archived, and distributed. So, for example, if onboard spacecraft data storage was ever reduced or lost altogether, the IC stations would be able to provide a copy of it back to Aeros. In that way, the ICs not only further enhance the ground station at Aeros, but we have other ground stations in Norway, Alaska, Germany, and Australia, all of which serve as the primary facilities for capturing data and tracking the health of the satellite. Now, in the grander scheme of things, Landsat missions have long been viewed as an important component of U.S. foreign policy. While certainly key to the country's science and technology policies as well, Landsat and the network of international cooperators embody the concept of a peaceful use of outer space, and with it, the worldwide dissemination of civil space technology for the good of all humankind. We had a chance to sit down and visit with some of these international cooperators recently at Aeros, where they had gathered for a Landsat Technical Working Group meeting. We know these folks bring a lot of technical support and assistance to maintaining a gold standard with Landsat of highly calibrated and reliable Earth surface imagery. We also know that they go back to their countries and share that expertise and guidance with local users who are developing locally focused remote sensing applications. We asked Vincent Rook, who manages the Alice Springs Ground Station for Geoscience Australia, what it means for his homeland to be an international cooperator.
The value it brings to Australia specifically, being a vast and massive continent, it allows us to perform analysis of land changes, natural disaster events when they occur, assist us in managing those, assist us in rural fire watching, and we have a Sentinel hotspot bushfire system. And it also assists us to basically the changing environment of Australia on continental scale, which we have different seasonal climates in Australia from North to South Australia. So therefore, the use of satellite imagery is just critical to make that assessment in government, industry, and business. So there's a lot of value of Landsat and satellite imagery in general.
So where would Australia be with its remote sensing capabilities without Landsat?
I think Australia, in some ways, because we don't have our own remote sensing satellite and the reliance on other countries, particularly US and USGS for Landsat missions, has been very, very useful. And our participation at the Landsat forums and other forums, Australia sees that as very valuable, and our knowledge of remote sensing and the use of imagery has been, I think, very extensive, and we have a lot of knowledge to pass on to others in the global forum. And I think our ability to interpret satellite imagery and influence future missions is where Australia, I think, has benefited the most from these forums and engaging in the Landsat forums in general.
The Republic of Korea has been an international cooperator for 4 years. Senior researcher Chung Hum-yu with the National Disaster Management Research Institute in that country told us, because Korea has a direct downlink from Landsat, those images can help it respond to emergencies much quicker.
In my country, we have some serious bushfire in Korea, so we lose a lot of the forest and the biomass in that time. But the important thing is, after the disaster happened, we need to know which areas are affected by the bushfire or the how much is affected and when it will be recovered for the previous condition. So using the satellite image, we can keep monitoring the more than 10 years. So we can analyze how it's changed after the disaster happened. So kind of we work like that. So international cooperators give the different method to measure that and analyze that kind of events. So we kind of increase the more capability for us.
Rook said Australia realizes those same emergency response benefits from Landsat.
Bushfires are quite devastating in populated areas, and checking and basically validating what the Royal Fire Services are seeing on the ground, assisting in those remote areas which are inaccessible, is just so important. During natural disaster events, flooding in major parts of Australia, like we had the recent floods in 2019, and huge sections of Australia, northern Australia, were devastated with flood, causing tens of thousands of livestock deaths. And basically, we're able to monitor that using satellite imagery, provide that information to other government agencies and the general public.
Disaster response is just one area of Landsat applications in South Africa, according to Dr. Paita Mangera, who recently transitioned as the manager of the Research Development and Applications Division for South African National Space Agency's Earth Observation Directorate, and now is the head of the School for Geography, Archaeology, and Environmental Studies at the University of Witwatersrand in Johannesburg.
Landsat data has been used extensively for water resource monitoring, for water quality assessments. So it has been very good in those areas, and for vegetation monitoring as well. So it has been used extensively for vegetation monitoring because it gives you a long-term time analysis for that. So if you are looking at long-term studies of vegetation, then Landsat is most the ideal sensor to use because it gives you a record from 1972.
South Africa has developed an advanced crop monitoring system that it wants to make available to other African countries. Mangera said Landsat is making that possible.
It will be difficult to do without Landsat because a lot of algorithms which have been developed are a lot more dependent on the spectral characterization of Landsat and the temporal resolution of Landsat. If you look at the spectral resolution of Landsat, it has got the most suitable bands for crop monitoring. You're looking at the red band, the infrared band. So those are quite important spectral bands for crop monitoring. It has got near infrared bands and it has got very unique thermal bands. There aren't as many satellites which are carrying the thermal infrared sensors as what we have on the Landsat. So Landsat has got also the longest time series of data. So for long-term applications, it is one of the most suitable sensors to use.
Beyond improved natural resources and disaster monitoring, there is valuable technical and development interplay that goes on among international cooperators as well, Mangera told us.
For us, it's a huge collaborative opportunity in terms of looking at new areas of applications for Landsat data, and as well as to develop new software. We just been able to develop a new ground processing software for Landsat 8 with the assistance of USGS. So that's a huge milestone for us as a new space agency. And as well as the opportunity to be able to identify new areas of collaboration where there are issues at the moment on analysis-ready data, where we're looking at new data structures. So the USGS has been leading that initiative, and we have been learning a lot from them.
The hope is that learning and collaboration will continue and provide even more possibilities and benefits as the launch of Landsat 9 approaches in early 2021. That's the expectation in Korea, Yu said.
The Landsat 9 is more developed, the sensor they have. So I think they are more accurate and more rapid monitoring in the Korean area. So it's really helpful to us.
You've been listening to Eyes on Earth and our conversation about the vast global network of international cooperators who not only help with the collection of Landsat data, but benefit from its acquisition as well. We hope you come back for the next episode of Eyes on Earth. This podcast is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.